Please let me unlock that. So I want to stay outside, you can stay outside, but lock it. I want to be locked inside. If you want to stretch your legs outside, you can do that. If you want to stretch your legs outside, you can. But I want it to be locked. The red key. Yeah, the inside one. Just the inside one. Leave the outside. Yeah, Chick, are you there now?
Yes, sir.
Okay, please confirm if you can see question number 38 on this. Can you see 38?
Yes, I can see it.
Okay, which of the following statements is not an advantage of an alkaline accumulator? So there are different cells that you can use to supply energy, EMF, or current to your circuit. So you can use primary cells or secondary cells. So amongst the secondary cells, you have your alkaline accumulator, your acid accumulator as well. Okay, so it's asking, which of the following statements is not an advantage of the alkaline accumulator? A, the electrolyte does not need attention. B, it can be recharged. C, it has low internal resistance. D, it has a much longer life than lead acid accumulator. Okay. Now, to put this in perspective, we need to understand what the alkaline accumulator is. So the alkaline accumulator, also known as the nickel ion accumulator. So that's the other name for the alkaline accumulator. It has a positive nickel plate and a negative ion plate with a solution of potassium hydroxide. That's why it is called alkaline accumulator, because it has potassium hydroxide is an alkaline. So it has it as the electrolyte.
Okay, I'm seeing it now.
Okay, you're seeing it now. Okay, good.
Yes.
Now, like all secondary cells, how do you know a secondary cell? If it can be recharged, the secondary cell, and that's an advantage. Simple cells or primary cells, they are not recharged. Once they are used up, they are gone. Now, they have low internal resistance, very, very important. And also, nickel accumulator or nickel iron accumulator has a longer lifespan than the lead acid accumulator, which is also a secondary cell. So you can see that 3 of what is up there is already listed. It can be recharged, it has low internal resistance, and it has longer lifespan. So with that, you can easily pick out the answer. What do you think is the answer with what I just stated so far? Which one?
Much longer life than the lead accumulator, lead acid accumulator.
No, that's an advantage. It's asking you for the one that is. If something has longer lifespan, that means it's durable, it's good for work.
Yeah. The electrolyte does not need attention, so.
Yeah, that's what it is. Okay. So let's move forward. Let's move forward. Okay, let me know when you can see my screen. With number 39.
I can see.
Okay. So make sure you tell your uncle that we covered a lot today for the time we missed yesterday, okay?
Okay, sir.
Yeah, he was trying to chat me up that we didn't have our class yesterday. Okay, the diagram above illustrates the wire connection to a 3-pin plug. The wire connection to a 3-pin plug. Now, the wires P, Q, and R, respectively, are what and what? Is it A, live, neutral, and earth? B, neutral, earth, and live? C, earth, life, and earth? D, earth, neutral, and live. Okay. So this is what is drawn. This is what I could sketch from what was given on the Q&A. But this is the actual diagram of a 3-pin plug. So you can see that the one by the left is always the neutral. The one at the middle is the earth. Whereas the one that is connected to the fuse is the live wire. So that means P is the neutral, Q is the earth, whereas R, connected close to the fuse, is the live wire. So with that, which option do you think is the answer?
B.
B, okay. So that is the answer already, but to put this more into perspective, so this is your 3-pin that you normally plug in. Most devices, they are connected to this 3-pin plug. You know what a plug is? Chika, do you know what a plug is?
Yes, sir.
That outlet that lets you plug something to the wall or to the switch so that you can use it. So most of them are having 3 pins. So that's why they call them 3-pin plug. The ones having only 2 pins, they are known as 2-pin plugs. Okay. So a 3-pin plug consists of 3 pins. The 3-pin plugs are designed so that electricity can be supplied to electrical appliances safely. So they are connected in such a way that they will supply electricity safely. So how do they connect How do they supply electricity safely because of the earth and other things? For the 2 pins, they are also known as class 2 electronics. 3 pins are known as class 3. 2 pins are pin. You see that they are mostly having only 2 pins. Why? Because they are not having the earth. Because the voltages going into them are very small. That's why they can manage just the 2, the live and the neutral. Okay. So the color of the live wire is always brown. That of the neutral is always blue, whereas that of the earth is green and yellow stripe. Okay. So the live wire is held at a voltage of 230, provides the current. The neutral simply helps to complete the circuit, whereas the earth is for safety purpose. Okay. So is it clear? Is it clear? Are you still there? Please let me know when you can see question 40 on your screen. Are you there now? Can we continue? Tika, can we continue?
Hello.
Yeah, can we continue?
Yes, sir, you can continue.
Okay, which of the following statements about parallel plate capacitors is or are correct? A, capacitance of the capacitor is inversely proportional to the distance between the plates. 2, capacitors can filter AC signals from DC. 3, capacitors can store charges. Okay, the options. A capacitor is actually a device for storing electric charges. The capacitance increases with area between the plates but decreases with increasing distance between the plates and also increases with the dielectric constant. So this is a simple diagram of a capacitor showing the plates. These are the plates, the Qs are the plates, have the positive and the negative metal plates. They'll have the insulator or the dielectric plate in between. So the more this distance, the lesser the capacitance. Okay. So what and what can you use the capacitor to do? You can use them to tune your radio circuit. You can also use it in the ignition system of motor vehicles. You can also use it to eliminate sparks in circuits that have inductance. Okay, so from the foregoing, yeah, so Chika,
Sir.
are you there? Please, you have to resend me this very question because the options there, they don't really seem to be consistent with what is supposed to be.
Yes, so it's meant to be I
Okay.
and I.
Yeah, something like that, but I'm not understanding what they have there, okay? So this is the symbol of a capacitor, but take note of these facts that I wrote here. I don't know. Maybe should I send you this soft copy? Do you need it, or are you writing down immediately?
So I'm writing it down.
Okay, right. So get all those. Okay, so let's move forward. So I think I left one unsolved. I think 41, which I'll solve later and give you. So if you see 42, let me know on your screen.
So I can see it. So I just send it.
Okay, I'll check it. Which of the following statements about magnetic lines of force is not correct? A pass through even non-magnetic metals. B, run from the North Pole to the South Pole. C, are in a state of tension and tend to be shortened. D, intersect one another. So solution, the region of space around the magnet in which the influence of the magnet can be felt is known as the magnetic field. The effect of the lines of force or patterns or nature of the magnetic field around a bar magnet can either be studied using ion filings or magnetic compass needle. And when you do this study, you find out that the magnetic fields run from the North Pole to the South Pole. Very important. Number two, the lines of force do not cross each other. They never intersect. They never intersect. And number three, the magnetic lines of force of the magnet is defined as the line along which the free North Pole would tend to move if placed in the field, or a line such that the tangent to it at any point gives the direction of the field at that point. So with that, you see that the statement indeed that says that it intersects one another is wrong because the lines of force do not cross each other. So that makes option D the answer. Are you clear on that?
Yes, sir.
Okay. Please let me know when you can see 43. Yeah, can you see 43? Can you see 43?
Yes, I can see it. I can see it.
Okay. In which of the following activities is an induction coil not useful? A, investigation of high voltages. B, study of electric discharge. C, operation of X-ray tube. D, AC power transmission. The induction coils are used to provide high voltage for electrical discharges in gas at low pressure, and as such were instrumental in the discovery of cathode rays and X-rays in the early 20th century. Now, an induction coil is an electrical device for producing an intermittent source of high voltage. And it's actually done by electromagnetic induction from low voltage DC source of a battery. So the answer should be AC power transmission, because induction coil is commonly used in motor car ignition and in operation of X-ray tube. You can already see X-ray tube here. You can also see high voltage here. You can also see electric discharge. Okay. Let me know if you can see question number 44.
I can see it, sir.
Okay. In a series RLC circuit, R is equal to 10 ohms, XC this is the capacity, XC is 4 ohms and XL is 9 ohms. So what is the impedance? Is it A, 4.1 ohm, B, 5.0 ohm, C, 10.8 or 11.2 ohm? Impedance is the overall opposition of a mixed circuit containing a resistor, an inductor, and or a capacitor. And it's measured in ohms. So we have XC to be equal to this and XL to be equal to this. But if you're calculating the overall impedance, it's going to be R squared plus the difference from what you get from the inductance and that of resistance from the inductor and that from the capacitor squared. So having that, this is what you have. But this, they're already given to you. So you simply get down to this last formula, because this from here is equal to this and this is equal to this. So you're giving this as 9 and you're giving this as 4. So you simply say 9 minus 4, which is 5 squared, 25. 10 squared is 100. 100 plus 25, absolute 125, which gives you approximately 11.2, making that the answer to the problem.
So please scroll down small.
Okay, this is the down.
Okay, so you can continue.
Okay. So let me know when you can see
I can see
45. A student uses 2 compass needles to investigate the magnetic field around a bar magnet. Which of the following diagrams show the correct direction of the needle? So what you're going to be looking for is locate where the north is and make sure the arrow is facing from the north to the south, because that's how it moves. That's how the magnetic field moves, from north. You see this north moving to south. It cannot be from south moving out and into north. So make sure That's what you should be looking for. Okay. So you have magnetic field is investigated using ion filings and compass needle. So the first question we had was on compass needle. This one is on ion filings. So you can see the direction of these arrows. They are moving from north into the south. Moving from north into the south. So you can see that in B, option B, is the north. You can see the arrow is moving out of the north into the south. You can see this is into the south. So you have to check the direction of the arrow and make sure it is from north to south. And that makes option B the right answer to this. Can we move on? Are you there?
Yes, I'm here.
Okay, let's look at question number 46. Which of the following particles may be emitted in a process of natural radioactivity? Is it A, alpha and beta particles, B, alpha and X-rays, B, C, beta particles and X-rays, D, gamma rays and X-rays? Okay.
Alpha and beta.
Alpha and beta, okay. That's true.
We did this one too.
Yes, natural emission. Radioactivity is the spontaneous decay or disintegration of nucleus of atoms of an element during which it emits alpha, beta, and gamma ray, or a combination of any or all of the three, and energy is heat as well. Okay, so you can see alpha and beta particle covers what we want. Okay, let's move on to question number 47. In which of the following situations is photoelectric effect employed? Where do we use photoelectric effect? Is it in 1, automatic device for switching on light at dusk? B, automatic doors in departmental stores? 3, automatic device for switching on air conditioners? And 4, automatic voltage stabilizers. We have A, 1, 2, and 4, B, 1, 3, and 4, C, 3 and 4, D, 1 and 2 only. I will check out the description. When light falls on metal surfaces, electrons are emitted in what is called photoelectric effect. So photoelectric effect simply means the emission of electrons due to light. That's why we have photo. Photo means light. Electric, as you all know, relates to electrons. So when electrons are emitted due to light, we have what we call photoelectric effect. And that phenomenon is utilized in photocells. That is the principle on which photocells work. So where and where can we have photocells employed? Photocells can be used in burglars' alarm, can be used in television cameras, can be used in automatic doors like departmental doors in the options. Can also be used in automatic switching of light, street lighting, and also in automatic digital counters. So those are where you can employ photoelectric effect. So with that, you can see the option D captures 1 and 2, which are clearly where photocells that employs photoelectricity can be used.
So we've done from 48 to 50 before.
Okay?
We've done from 48 to 50.
Okay, I've already done 48 to 50 with you, Abby. that what you're saying? Hello, Chika. Chika, are you there? So you said we've done this one already. That's what you're saying. Which of the following radiation has the longest wavelength? I would say it's radio wave, isn't it? Because radio wave has in the dimension of 10 to the power 4. The shortest is that's of wavelength is gamma ray, but gamma ray has the largest frequency. We've also done 49, which is in which of the following fields is radioisotope not useful? Radioisotopes, they are used for medicine, agriculture, but not in weather forecast. They are also used in oil exploration. So weather forecast is the answer. Then finally 50, a nuclide is represented by this. Determine the neutron-proton ratio, okay? So this is the atomic mass. Use it minus this one to get the neutron. Then find the least ratio. Okay.
So we'll choose
that
41 now.
Huh?
Number 40 and 41. 40 and 41.
40 and 41. Okay. I'll work on those two and I'll get back to you.
Okay, sir.
So while I do that, I want you to let's work on 2020. Okay. We need to work on 2029 for physics.
So
Then 2020. Yeah, I'm listening to you.
So I didn't hear the year.
No, I didn't.
So what year did you say?
Okay, I'm saying let's work on 2020. That's 2020 for chemistry, since we are done with 2018 and 2019. For chemistry, 2020.
Okay,
then
sir.
For physics, we are working on 2019 of physics.
Yes, sir.
I hope that's cool.
Yes.
Okay, so by then we must have been done with 3 years for chemistry and 2 years for physics. Then we'll keep going. We are very good. Okay.
Okay, sir. I'll send the question for 2020 chemistry.
Yeah, please do. Okay,
Thank you,
so with that, we'll come to the end of today. See you when I see you. God bless you.
Okay, so I'll be waiting number 40 and 41.
Yeah, please, I'll do that. Possibly tomorrow, I should be able to send them across to you.
Okay, sir. Thank you.
You have to snap them since they are the only two. Let it be very clear, okay? So that I don't have problems.
So we can do only two.
Huh?
I should snap 2019 for physics.
No, I mean the problem, the one that we did not solve, those two, snap them boldly. Then you also snap the.
I snapped it and sent it.
Yeah. Then you also snap the 2020 that we want to do for chemistry, as well as the what's it called? 2019 for physics.
Okay,
Yeah.
sir.
Thank you.